So exercise 10e, question 7. We've got two particles A and B with masses 6 kilograms and m kilograms, and they're connected by a light and extensible string. Particle B hangs to below particle A, and there's a force of 180 newtons applied vertically upwards, causing the particles to accelerate at 2 meters per second. So we need to find the mass of particle B and the tension in the string. So the way we're going to deal with this is, as with most mechanics questions, we're going to take the paragraph and turn it into a diagram, nice big diagram, so that there's room for everything on it. B is hanging below A. A has got a mass of 6 kilograms, which I'm going to put on the diagram as a force of 6g newtons downwards. And B has got a force of, a mass of m kilograms, so that's mg newtons downwards. There's a tension in the string which is pulling B up and is pulling A down, and there is a force applied up here, 118 newtons. Now, how do I know that this force is applied up here and not a pushing force on B? And how do I know that this string is taut? Well, in the question it says that this is light and extensible string connecting A and B. So if there's a pushing force on B, then this string would go slack and A wouldn't accelerate. Maybe I could hold A still and A would accelerate, B would accelerate upwards. But the only way to have one force making both of these accelerate upwards is if I'm pulling A and then B is being pulled upwards behind it, and this is hanging vertically, so the string must be taut. It's a light inextensible string, so if there's no stretching, the tension has to be the same all the way through. So the first stage is getting that diagram down. Now once we've got that, we think of, instead of going straight in and thinking, well, how can I find this mass? I would go for this, well, it's a connected particles question, so we could consider A. Let's consider just what's going on at A. Well, A is accelerating, so all the motion is vertical, and we're going to have to apply F equals ma. The forces won't balance because there's an acceleration. So just at A, cover up the rest of the thing, this is what we've got. We've got 118 newtons pulling upwards. We've got 6g and t pulling downwards. The mass is 6 kilograms, and the acceleration, I've not put the acceleration on my diagram in fact, but it is 2 meters per second. There we go. And I'm taking upwards, that's my positive direction. So that is, we can make that a little bit neater. I suppose we could have 118, 6 times 2 is 12, so 118 minus the 12 and take these two over the other side, so 106 equals 6g plus t. Oh look, I've just found the tension in the string, it turns out, which is part B of the question. So tension is 106 minus 6g, well 6g is about 60, so 106 take away 60. Let's just see if we got the right answer there. Hopefully we have. Um, 106 take away 60 is yeah, sorry, that is about right, isn't it? 6g is not exactly 60, it's about 60, and my head was failing to do 106 take away 60 easily, so 47.2 is the exact answer. 106 take away 60 would be about 46, so slightly less than that. Okay, so that, well, accidentally we've done part B, but never mind. So consider the motion at B would be the next thing we'd do. Well, at B, again, it's vertical motion, and we're going to apply F equals ma. The tension's pulling upwards, mg is pulling downwards, and that is the mass times 2 on the right hand side, and there's not much I can do with that. So equation 1 is going to give me the tension, well, we could leave that, let's just say tension equals 47.2 newtons. That's fact number 1 if we want to use it. This is fact number 2 if we want to use it. And the third thing I'd do would be I'd think about the whole thing together. So we'd say A and B together. Well, if we consider them as one particle, then we have 6G, so consider A and B together. 6G pulling down, 118 newtons pulling up. We've got an acceleration of 2 meters per second. So overall, vertically apply F equals MA, 118 minus, 6G plus mg pulling downwards. 118 minus 6G minus mg equals, the mass is 6 plus m times the acceleration of 2. So that's equation number 3. And then if I look at these 3 equations, between them they should sort out what I want. Now, as it happens here, you've probably realised I didn't need this third equation, but it's good practice, at least in your head, to think what are the things that I could apply here. I could do motion at A, I could consider A separately to B, consider each of those on their own, and then I could consider A and B together. In this question, we found the tension from that one there, and then applying that to B, we're going to be able to find 47.2 is the tension subbed in from one, so I should say that, shouldn't I? Sub in from equation 1, that's going to give us 47.2 minus mg equals 2m, and if I solve that equation for m, then we should find m. We didn't need the third one, but in another question they might have given us another unknown. Say the mass of A was unknown as well, and we'd have to work that out, so we'd need the third equation. So if you're happy with that, you could probably stop the video and finish that off for yourself from here, but let's just check. M is what we're trying to find, so let's put all the m's on one side. 47.2 equals 2m plus mg. 47.2 equals m brackets 2 plus g, and well, 2 plus g is 11.8, so 47.2 divided by 11.8 equals m, and that looks like 4-ish, and I remember from when I just looked in the back of the book that m was supposed to be 4 kilograms, so let's see, 11 times 4 is 44, 8 times 4 is 3.2, so yeah, so m equals 4 kilograms. So if you're on an exam, everything above this wiggly line is what you'd want to write down. Of course, you wouldn't want to write it down here and then squeezing it in like this. You want to write it straight down the page, but that would be a perfectly good answer, I think, if you're on the test. You should be able and prepared to do this bit as well, though.